All right, let's dig in. So I just want to make sure we're aware that there is residential and commercial duct testers that Retrotec has. So we're only going to focus on the residential. Next week, same time, same day, we will focus on the commercial side of duct testing, which is a whole nother animal all in itself, completely governed not really by codes, but actually by the engineer who designed the system. They decide what and how and the compliance really is. So today it's all residential. One of the questions that I want to get out of the way is what's included, or what else do I need? The reality is everything you really kind of need is all included in the system. So they kind of alter some of the tubing that you get, but in general, everything you really need to get up and running right out of the box instantly is there, including the quick guides, which makes life very simple. So you get one for the how to do a duct test, and you get one for your gauge. They're all very intuitive, and everything is designed to be user-friendly. Some people call idiot-proof, but we keep making better idiots. So I refer to it as fail-resistant. So everything's color-coded and very intuitive, that you really understand exactly what you're doing, what your setup is, and really avoid some of the most common mistakes that are out there. I want to give a plug for those of you that are using the duct masks, which you almost always need to, that these are two options that are out there that, we can, you can go to them directly to buy this. I believe we have VentCap, or Retrotec has VentCap on their site. So, so your ducting options on the left is Corey Breed with VentCap Solutions. And he has a system with the poles. Russ King is on the other side, where he has a system where the pole stays in place, but allows you to do stuff like on the wall or a variety of other stuff. So anyway, I wanted to make sure you knew there were some options out there to seal your ducts for your tests as you do them. Okay, so today we're going to talk about the requirements, who can perform the test in general, and total leakage, leakage to outdoors, and some alternative duct test methods. This is actually the chapter and verse from 2009. We'll talk about 2009 and 2012 separately, and then actually combine them about how to do the test. So they gave you lots of options when they first started this test, and they gave you a huge amount of leakage to comply with. So you could either do leakage to outdoors test, which again is only 2009. I have a summary slide that'll kind of go through these to make sure we actually can take all this in, but it's really pretty straightforward. Now, some people may have adopted 2012 to be 6 CFM or 5 CFM or something else, but in general, that's actually what's in the code. So for 2009, which is when this all began, you have the option of with an air handler or without. It's actually difficult to do that test without a air handler, but some people have done it, and those are your requirements. Or you can do a post-construction, which means that you have drywall in place and all of the, it's almost ready for occupancy. And then I can actually use a blower door combined with the duct tester to do leakage to outdoors, or I can do a total leakage of 12 CFM, which is a 12% of your leakage is a huge amount that, again, your homeowners are not paying for and are not receiving. They're paying for it, but they're not receiving it. So that's a chunk of change that is acceptable for code. 2012 said, okay, for those of you that have joined us in 2009, those were some easy numbers to hit. All right. Now let's step up your game and really get your ducts much tighter. So if you're still working on 2009 and feel that your 12 CFM is easy to do, you really should be finding yourself testing out at numbers that are closer to 6 or 5 or even 4 already, because as soon as 2012 hits you, some people are jumping to 15. 4 CFM is really, you got to be on your game to make sure everything is sealed, including the registers or the grills at the drywall. That's one of the most common places to have leakage. You still can test without an air handler for 2012 and 15, but you're down to 3 CFM. And they got rid of leakage outdoors. Again, some people are bringing it back or have kept it. Michigan has kept it. And your total leakage, again, is 4. So your number to shoot for is 4. 4, 4, 4 all day long. There is an exception that's in all of the versions, which is it's not required if your ducts are in the building's thermal envelope. It's not necessarily conditioned area, but thermal envelope. That is a definition in the code, but it's also a huge interpretation upon your jurisdiction. So if you're not sure exactly how that is defined, I definitely recommend you refer to your own building official, and I would try and go to the most knowledgeable building official that can actually try and give you some information. I just recently did a rough-in test. I usually don't do these, but there was a job site down the street, so I went over and coordinated with how I could do a rough-in test, and I found this to be the easiest and greatest test to do. You should still do a test just before occupancy because that's really when you want to find out if you have problems. But if after the install, this is a great time to actually determine, yes, everything is okay. The last thing you want to do is find out if you have a two-story building and you actually have ducts that are running through the floor between first and second floor, to find out later that there's a leak because you're tearing open drywall to do that, or maybe in the wall cavities where you have a separation. So there's a couple of methods of sealing your duct system. This is the most common question we kind of get when we do this is rough in. So you can still use your grill mask, and it depends on what kind of boot you're using. Most of the boots now are have the drywall flange around the edge, which means they have a little perimeter right here that actually allows the drywall to sit up flush against this area. That makes using the duct mask fairly easy. If it's the old style boot that has nothing except just an end on it, that's a little more challenging to use with the duct mask. The other option you have is some kind of foam or some dense options. So this can be expensive if you're going to buy a bunch to do various tests. I went to my local Goodwill store, told them I'm looking for a bunch of foam, and they gave me a call, let me know they had some old couches that they weren't going to sell because they were messed up, but I could come by and buy the foam. So for $13, I got about $200 worth of foam, and I was able to cut it up and was able to make a better use of what they would have just thrown in their trash anyway. So anyway, that's one option, to go to your Goodwill and see if you can't find some really dense cushions. So I cut them up into chunks and was able to use them for most of my rough-in tests that I had to do. All right, I'm going to dig into the test itself. Jay, any questions or anybody have anything we want to address real quick?
There was a couple of kind of esoteric questions here. We did have a question: why does the grill mask that we include in our systems break into 12 by 12 squares when most grills are 14-inch? And I offered that it's just easier to manipulate it in cases where the grill is not a common size, not a 14-inch.
I don't know if there's the option to have it cut at 14 or not. So, yeah. So we can pass that feedback on.
And then Joe, I want to throw this one at you. So early in your presentation, I think it was the slide with the lazy cat. There were some books on the side, 3 books on that slide, and Stephen wants to know if that's actually available. Those books are available in Britain.
That I do not know because I borrowed that slide from Google Images. So I apologize that it's not my cat nor my office that comes from. So yeah. Anything else?
Carry on.
Thank you. Okay, so one of the things that I really has always attracted me to things that Retrotec does is their field guides and how their system is just so user friendly. And their field guide has lots of pictures. Now the gauge has got similar imagery that you can confirm what you're doing, and it steps you through with little check boxes actually on what you need to do step by step, how to do your duct test, depressurization, or if you still are insisting on pressurizing, then you have those options. But it guides you through both of those scenarios. So you open your test guide, your quick guide, and we're going to seal our ducts. We're going to remove the filter. We're going to make sure there's no other air handler moving air, and we're going to make sure we have all of our tubing connections and set everything up and run our test. So one of the things you want to make sure you're prepared, the ducts in the house are, again, we have all of our air handlers off. Everything is sealed. Filters are removed. Some people say if it's a clean filter, it's okay to leave it. But I don't. I usually just pull it out just to make sure there's no issues. Make sure that's also covered, depending on what kind of slot it is. There should be no other systems moving, including obviously the HVAC system or other exhaust fans or clothing dryers. People are like, oh, it really shouldn't matter. But your goal is you don't have any other pressures that you could feel that influenced your test, depending on how tight the house was. You should make sure, you must actually, so it's not a should, this is a do. You must make sure that the ducts are open to the exterior. Otherwise, your pressures may not be accurate or become altered. So the example is that we're going to make sure that we reference the inside of the house in order to make sure we have 25 pascals in the ducts. And then what happens is that the duct tester is now, depressurizing into the ducts or pressurizing. It's causing pressures in the house. And it depends on how small and tight the house is. Those can actually impact your reference that you're trying to get as a pressure difference. So you need to make sure that the interior of the house is open, open a small window or a door. Also, the same as if you have your air handler in the garage, or if you have ducts in a really tight, well-sealed attic or crawl space. All those must make sure that they're available and accessible to the outside. If you can imagine a real small attic that's really well sealed, a sealed attic, that at a certain point, if there is some kind of leakage, it has very little place to go. So the area around it, the air around it, can create an artificial barrier. So again, you want to make sure the hatch is open, so that any kind of leakage is able to leak to the outside. Okay, so we're going to step through some pictures here. So I convinced my son to give me an afternoon. So we seal off all reply registers and the return frills. If you notice that in the bottom left, sorry, Jay, make sure we catch that. We're going to insert the blue tube into the supply duct. It technically needs to go nearest the air handler. If you're working on a system that may not be new, or even new, you can still have the same issue. If you do want to check and make sure every now and then that you do have pressures at the furthest duct, because something may have happened in terms of some kind of clog or separation. And we're going to talk about some zonal dampers that also could be a problem for you. So normally it's at the nearest supply. But if you want to make sure that everything is air is flowing evenly throughout the system, we need to go to the end, or even individually if they have zonal dampers. So we connect the flange seal to the main return. It should be the most largest area that you can actually move air through. So that's actually what our goal is. Usually it's the one nearest the air handler. We connect the flange to the flex duct and to the duct tester. So for the Retrotec system, everything is color-coded and makes things very simple for you. So you're going to connect, obviously, the yellow and green tubing. They reference both sides of the duct tester, so that if you want to reverse it from pressurization to depressurization, all you have to do is turn it around. There's a Ethernet-style cord that actually connects from the fan to the gauge, and the blue tube is what's going to go, again, all the way back over to our nearest supply duct. And we're ready to run a test. So the readings that you're going to get are based upon the amount of pressure or air that's moving through the duct tester. So if I have too much or not enough air or pressure in the duct tester, I'm not going to get results. So we're going to start with plug 74. Many people refer to these as rings. It's the same kind of concept. It's basically a calibrated orifice that we want to make sure we are able to read the pressure that goes through. So there's a great debate about pressurization versus depressurization and which to do what. To my knowledge, only California says you must pressurize your ducts. So if you have anybody else stating that otherwise, please let us know so we can kind of keep track of that. But in general, we highly encourage you to pressurize. I have a few slides to explain why that's such a vital thing. But if you need to do both, then you can turn it around. Based on my experience recently doing the rough-in test, that you definitely should depressurize first and get your numbers, and then pressurize. And if your number suddenly becomes larger or doesn't really match closely your depressurization test, something came loose, because that's one of the issues with pressurization is you can actually blow open any kind of duct mask or duct seal. So I was doing some testing in my house, and the difference between pressurization and depressurization. And this is what I found after I pressurized, is that I could see that there were little gaps around the duct mask. And if you imagine that there were, 18, 15, 12 of these registers in the house, that little bit of leakage can add up. And if you're trying to get to 12 CFM, it probably wouldn't make much of a difference, or 12%. But if I am trying to get 4% or 4 CFM per 100 square feet, this are the little things that can actually make a huge difference for you. So when I depressurize, this duct mask gets sealed really tightly to the drywall and to the grills themselves, and it makes for a much tighter and slightly more accurate test. My goal is to measure the leakage in the ducts, not to add any artificial leakage due to my challenges on sealing off the system. So that's why depressurization is definitely a better method. When you are depressurizing and you're using the Retrotec system, it's important to know that the rings or the plugs actually end up inside of the flex duct. So if you need to change them, you disconnect the flex duct and either add more flow through with removing a plug or tightening up by adding a smaller plug. Okay, so we can conduct a test. So there's two ways you can do it on the Retrotec system, similar to the Minneapolis, but here you're actually easily able to do what they call the cruise, or for us it's just called set pressure go. But you can also use, there's a speed control knob on the fan itself. So some people forget that, or if you're in the field and your speed control cable doesn't seem to be, has an issue or got stepped on, you can still do the entire test by reading the pressures that are in the gauge and controlling the fan just with the speed control knob that's on the side of the fan. So I usually describe people as when you turn on your gauge, you've been doing this for a while, follow the quick guide, but when you want to make sure you just check a few things. So I confirm that we're on pascals. And one of the great features is when you open your DM32 smart gauge, whatever your settings were from the last time, they stayed in there. So if I'm always using a duct tester, it stays on there. If I'm always using CFM and pascals, all that stuff stays in there automatically. I don't need to reset up the gauge every time I turn it on. So I got pascals, CFM. There are some different results that you can get in your gauge. We'll talk about that in a second. I confirm I have the right device and the right range, and confirm what's on the fan, which is the visual part of that.
Hey, Joe.
Yeah.
I got a couple of really good questions. I want to apologize for the if you can hear the car in the back with the alarm, but I've got a couple of good questions here that are about slides that we just went over. First one asks, should the tape be applied to just the register grill or to the sheetrock around the register?
Great question. Sure. So I said first, so unless your jurisdiction says otherwise, it is considered a best practice to seal all the way around the grill to the drywall. And the reason is that if you visualize the drywall and where it actually connects to the boot and the register, that when you actually can seal that, then you actually end up with leakage. Because we're kind of go back to the attic, so that is still leakage. Sometimes if you end up letting it flow back into the house, it won't be acknowledged as actually a leakage. So that's one of the things they do, especially if you're also going to then do any other type of leakage outside test or anything else. It's your goal to make sure you're acknowledging that issue. The other one is that comes up a lot is that what do I do with a floor and carpet? So I highly encourage people to make sure that they mastic the boot to the carpet, that the carpet should be well tacked, and that whole area should just be sealed completely. That you should be masticing the carpet and the boot so that whole section is sealed, so I don't end up with leakage that ends up and underneath the carpet or moving in other parts of the flooring. And to clarify, my preference is depressurization, that you get the best, tightest, most accurate leakage results when you depressurize. It's when you pressurize that you can end up with artificial leakage based upon your sealing system. Anything else, Jay?
Just somebody was looking for sources for duct mask. Suggested sources.
Yeah, you can get a hold of us, sales at retrotec.com. They sell the blue there, so that's actually a resource. They sell it in rolls of 3. And the reason it's blue is so that you can easily identify it before you leave the house. It used to be white, and people were leaving it on a few registers because they looked up and didn't really realize that it matched the ceiling. So it's now blue, so you can kind of catch your eye as you leave the house. Okay, so I confirmed my settings. I made sure everything was correct. And basically, to run a test, I hit set pressure. I enter 25. It doesn't matter if you're pressurizing or depressurizing. The gauge knows what you're going to do, and up and running. So here I'm performing a pressurization test because it's 25. If it was depressurization, it would have been negative 25. So we turned on the add feature, which gives me the extrapolation feature that's reading right below 184. So it says I have CFM at 25 pascals. So again, the add feature is designed so that if I wasn't able to reach 25, then it would still give me my results as though I had reached that. So the fan is running, and I now have my results, and it only takes a few minutes to confirm what you've got. And the most difficult part about these tests are covering and uncovering the grills and the registers. So I got a few more things. I'm going to skip through one or two of these slides. So okay, here we go. So let's start with I can't reach. First thing I have to do is I have to reach test pressure. So let's say that I'm doing a test and my gauge does not reach the test pressure that I wanted to. So I need to reach 25, but I do not have 25. So the thing to do is then you need to let more air into your system so that I can actually add more pressure into the ducts so that I can get to my test pressure. So again, I'm not after results just yet. I need to make sure I've achieved test pressure. So we start on range 74, but I'm only able to get to say 19. So even if I had open up the fan completely to open, I changed my settings in the gauge to I'm now at open, but I still, no matter what I can do, I can only get to 19. If this is a new house, you have an issue. That there's no reason that any of the manufacturer's duct system testers cannot actually test an adequate system without a question. So right now I know there's something that's disconnected because I can't even get to 25. But some of the stuff may actually apply to an existing house. So when I turn on the add feature, it's going to tell me what my results would have been at 25. So if somebody needs to come back and fix something, then I can confirm that results previously were at 25 and my next set of results were at 25 also. So that the add feature is kind of like your last result when you can't get to 25, but in general, I turn it on all the time. So once I've reached 25 pascals, but I have no results. So my gauge at the bottom is just giving me the dashes. So I do not have actually the test results. So now what I'm after is I need to allow more pressure to be inside the fan so that the fan can actually work with the pressures inside to give me my calibrated results. So I started with the 74 range, or the plug, and now I'm going to swap it out and put in the 74. So you don't need to stop the fan, but you can. But I want to make sure that you change the gauge. That's the number one error that most people make, is that they're actually change the range on the fan, but they forgot to do it in the gauge. And then they go back and start testing, and that can actually create some incredibly false results. All right, so here's a new one I just added for this webinar. I've been trying to add it and had time today to put it in there. Someone said the standard pressure was 50. The only place that used to use 50 pascals to do testing was the Northeast, up in the Oregon, Michigan, or Washington State. Some of those were areas that used to do that, but it was more of a weatherization or a general practice. If you're going to follow code compliance, it actually states that you must create a pressure difference in the ducts of 25 pascals. Okay, so one of the things that is a common occurrence possibly in your area, like usually if it's there, then it's there a fair amount. Like when I lived in Arizona, this was a common occurrence for many of the duct systems that were there, is that they actually had zonal dampers. Zonal dampers are basically an electronic damper that determines which ducts are open or closed. Sometimes they can just be like for upstairs or downstairs, or they can actually be in individual rooms. So that if the master bedroom wanted more heat or cooling, it could turn on the entire system, but the only place where air would flow would be into that room. So those are more of the advanced types of scenarios. I'm not going to go into whether they're good, bad, or indifferent, but let's talk about how to test them. So if you find out that your system has dampers, or if you can't get pressures into your duct system because you're depressurizing or pressurizing, but I'm like, wow, I cannot get 25 pascals in any of the registers, you probably have zonal dampers. Zonal dampers can sometimes, in their off or natural position, be closed or be open. There is no set standard, nor is there one set way that they always are. So people say, oh, northern climates or cold climates. I work with a group here in Atlanta where it's cold enough and hot enough that we have both. So they can go into two houses in the same subdivision and find they were actually set up differently by that individual HVAC contractor. My scenario is to help you determine whether they're open or closed, and how you can actually use your gauge to confirm that all of them are open, so that when you do your tests, you're not restricted. So if I just did a test now, I probably wouldn't even be able to get to 25 Pascal difference. But depending on where the dampers are, I may have got false indications. I may have had several rooms where the air actually was never going to them. So these are my zonal dampers that I've got. On the right side of the illustration is the return. So those usually don't have a damper system. So on the left are my supply. So I tried to describe that you could have an entire truncated supply, or you could have individual or smaller takeoffs that are also dampered. So let's go through our scenario on how we can confirm. So you set up your duct testers you normally do to depressurize. And now I need to go around and check each individual register to confirm that I do actually have pressure into it. You can actually do a scenario where you actually try and compare pressures from the plenum to other parts of the duct system or to the registers. But in general, I just need to confirm if I'm getting my 25 pascals. So if the damper is closed, I'm not going to read any pressure. Maybe you get a few pascals just from leakage around the dampers. But if I'm having no pressure at all, I clearly know that this system is a closed system and currently unable to allow me to do the duct test. It's not easy to open up the dampers without turning on the system. So you need to make sure, if you're aware of this, that your HVAC contractor has educated you as to how to do this, or they're there to allow you to make sure the dampers are open or confirm that they're open. So once they're open, I can now go, okay, great, I have 25 pascals. This part of the duct system is open, but it's in your interest to go around and check all of them. So if I go to the next one and go, oh, wow, I thought this whole area was open, but maybe the master bedroom actually has its own isolated dampers. So this one is closed and I'm not getting any kind of flow. And I can go to another one and confirm that it is open and I'm getting 25 pascals. I do not encourage you to mess with the dampers or try and open them manually or do anything else with them, because those are very expensive systems to install or maintain. So it's not something you want to try and figure out yourself. You definitely want to refer to your HVAC contractor.
Joe, are you going to talk a little bit about fresh air intakes?
I'm not. One of the things that I need to make sure is that damper is closed. So sometimes you actually have a fresh air intake that I'll kind of describe it with my mouse here, is that I may actually have an intake that goes from the outside. We'll just say it's from the roof into the return, and it's what they refer to it as fresh air or somewhat makeup air. I really don't think there is such a thing as fresh air. Personally, that's my own IAQ theory, that it's just air from outside. So I have air from outside that's replacing or making up from air in terms of how tight the house is or other ventilation concerns. So that damper must be closed. It normally is. So you would want to make sure that also was something you would could have a huge artificial leakage by having a 6-inch duct typically just going to the outside. Is definitely it's not something I'm trying to close, or it's not a requirement that gets closed, but I need to make sure that the damper is in a closed position. Hopefully that answered the. An economizer is more for a commercial application for Mark Lara and Mark. That's actually next Tuesday. So I won't talk much about economizers in general, but I will talk about what those are. An economizer is where it actually uses the temperature of the air outside to help temper the air for the interior part of the area. So when you go to any kind of commercial place, especially like a theater, and you wonder why it's really hot or cold, it's because they're using outside air to try to condition that to save money. Thus the word economizer. Okay, here we go. We're going to start from the beginning and run through, and then we're going to do leakage outside. So you must have some kind of window or door open. Again, I want to need to make sure I have access to the pressures evenly. So if my attic was well sealed, I should have opened up a hatch, but we're going to assume that's a well ventilated attic. All of the ducts supply and return are completely sealed, whether I use duct mask or an alternative method. I connect the flange to the largest return nearest the air handler. Sometimes you may have to go to the air handler itself if you have individual returns. It still is a very common practice here in Georgia that they put individual returns in each room. So if you do not have one large central return, you're going to be forced to go to the air handler and set up your duct tester at that location, because otherwise you're going to have significant back pressure that will affect your readings, or you won't even be able to actually get to the test pressure you need. So again, you must have some kind of large a duct system in order to pressurize or depressurize your system. All right, so we install our flex and we're depressurizing. Again, notice that our ranges, our plugs are inside the flex. And our next step is to get our gauge. I'm going to make all the connections. These are all the ones that go. So my blue tube is going again to the nearest register or supply, the air handler, and these are the connections that go directly to the gauge itself. So again, the blue and green are referencing both sides of the duct tester, and the other one is actually the speed control. So I can control this automatically. So we depressurize, and now I actually am able to get my leakage. So according to this, I have 140 CFM, and we're going to talk about code here. So let's move into, if I have 140 CFM divided by the square footage that it serves, and it gives me 5.6 CFM per 100 square feet. Depending on what code you're on, you may be doing really well, or you still have failed. So that's actually the difference on, it wasn't that long ago that 6% was a great target number to reach. That was actually Energy Star. That was actually like a heck of an achievement to have gotten your ducts below 6% or 6 CFM per 100 square feet. Those days are gone. So the real purpose behind much of the code that we talk about was to convince builders or HVAC installers to put your duct systems in the building envelope. Put them into the thermal barrier so that you don't have to test, and everybody wins with a much better option. I disagree with the fact that you don't have to test. I still think you should test, and all the air should go where it belongs. But their goal was to say, hey, stop putting them into the attics where it's incredibly cold or incredibly hot, or all of the moisture issues that come along with the crawl space. So I see in about another 10 years or so, having ducts outside of the conditioned or thermal boundary will be a rare occurrence. So they are headed that way. And I also feel that we'll always continue to test them, even if they are. So that exception will probably go away fairly soon. All right, so pressurized, not much actually has changed here. All the things stay the same. We turn the fan around, and we pressurizing the system, again, to 25 pascals, and we get our results. If you do this in the field, you may find that your results are not exactly. You're not going to get exactly 140 depressurizing and 140 pressurizing. The leaks have their own ability to, when I depressurize, I may actually pull the leaks slightly together. When I pressurize, I may expand them in a certain way that's more than what they normally have. In the process, you're not going to get the exact same numbers. Air doesn't move through its openings in the same way in different directions. So you always get a slightly different number, but they should feel very close to each other when you do the test. Again, you do not have to do any duct testing if the air handler and the ducts are within the building thermal envelope. My feeling is it takes about 5 years for builders or the HVAC contractors to convince one or the other to do this and bring it into the thermal envelope. Okay, so I do believe we have a slide that shows the. Oh, here's one of the ones I'll go briefly. And people wonder, why is duct leakage an issue for infiltration? This actually is causing air leakage on the envelope, is because these things are moving an enormous amount of air. So the air handler, let's just say that it must move 1,200 CFM as just a number to compare. And each one of my arrows is half of that. So if I lose half of my air in a supply leak, but that motor is still moving, it says I still need 1,200 CFM to come back. So 600 does go into the house, but it's going to say I need a bunch of air to be made up from someplace. So it's going to pull air in from wherever it can. And if you have any kind of combustion appliances that are directly connected to outside, now you actually have an issue where I actually have items backdrafting. So supply leakage sucks, and it can also cause significant issues in the interior, the envelope, which have nothing to do maybe with your duct system, but do have enormous to do with the occupants and comfort issues. The opposite for returns, again, now where's my air coming from? It may be in the crawl space. I'm getting a lot of nasty, cruddy air from the attic or below. And if this is a northern climate, I now am pushing moisture through my walls to the exterior, where that kind of moisture can actually freeze and cause damage to the structure. All right, I want to make sure I have a slide that shows the math real quick. So I don't have my, I'm waiting to see what's my next slide, and for some reason it decided to hang. Wow, I swear I had that. All right, let me just grab it here real quick. I've tried to put it all together, and I had it from a previous slide, but it did not show up, or must have got moved over. So 1 second.
Hey, Joe, while you're looking for that, I just want to clarify that in none of the code does it require that you test ductwork if all the ductwork is inside the thermal boundary. So I had a few questions about that, just looking for some clarification.
Yeah, it says that if the ductwork and the air handler are completely within the thermal boundary, then you do not have to do that. Duct testing is not required. Now, you may have jurisdictions that say no, you still have to do that. But in general, if you just follow the body governing body, it gives you that exclusion to not have to do that. So here's one of the slides that I thought I had in here. I apologize. So let's just say I have a home that either has split floors or split half and half. What I need to do is determine how much of the square footage is assigned to each air handler. And it's easy to do when it's individual floors, from second floor, first floor, or basement. But sometimes you have them split on the same floor, and you need to make your best educated guess as to who's serving who. Sometimes you have issues with foyers or common areas. So your goal is to make those, the best you can. And what you do not do is you do not add up, again, do not add up square footage and leakage in terms of your test, and assume that, this one may fail, but this one passed by a lot, and I can average them. The correct practice and how it is assumed is not written, but everybody makes sure this is the point, is that you must test each individual air handler and system by itself based on the square footage that it serves, and it must pass. So here I have air handler 1, which may pass, but air handler 2 has failed, so this whole job has actually failed. So you cannot, again, combine systems. You must test each system independently and individually based upon the square footage that it serves. And here's the leakage and how that kind of works. So if I say I have a total leakage post-construction test, this is the most common test that everybody does. I get 107 CFM for a 2,400 square foot area. So your math is 107 divided by 2,400. You times that by 100 to get a percentage. Percentage is an easier word to say than per 100 square feet. So here's where those numbers come from. So on the gauge is where my CFM comes from at 25 pascals. Then here's what your math. You have 107 divided by 2,400. It should always end a 0 point something something number. And then I times it by 100 to get me into the percentage or the actual per 100 square feet. So here I end up with, we'll round it up to 4.5. And what's really amazing is that I can get these exact calculations directly in the gauge themselves. So instead of getting CFM, I can actually change the gauge and get those results by just changing my options in terms of CFM to CFM per 100 square feet. Any other questions, Jay?
The only one that we have is any differences for testing high velocity duct systems.
I don't know. So I've learned a while ago that if you don't know, oh, there it is on here. I couldn't find that. It probably was the next slide. And is if you don't know the answer, then you should just fess up. I don't know the answer. So
well, here I can say this.
Yeah.
This is something that this is an answer that Colin wrote, and he's not here right now. But I can tell you that he said that those duct systems should be tight enough that it does not matter where you test it from. He said he recommends that you test under negative pressure to ensure that you get good seals at the registers. And then he wants to make sure that that it's low enough that you have the correct plug in there. And he just said when measuring super low flow, do a field check of your duct tester by cutting a 1-inch by 3-inch hole in a thick cardboard and tape it to the flange on your duct tester. This hole should come in at about 16 CFM at 25 pascals with the pressure measured across the cardboard. If it measures more than that, your duct testing system could be leaking or out of whack somehow. So basically what he's saying is it should be extremely tight. It's because it's a high velocity, high pressure system. You can test it from anywhere. And and if the duct leakage is relatively low, the pressure in the duct system will be pretty uniform in either location. So give it consistent results. So hopefully that helps.
All right. Couple comments. Someone says about the stairwell. How would I usually just would take the stairwell and just divide it in half, but usually it's an area above and below. So my time is tight. There's a lot to cover, and so I got 5 minutes. I will not be able to finish leakage outdoors, but I'm going to dig in anyway. That's just how we do it here. So I feel it's a great topic. And I added a few more slides to try and clarify some of the challenges that go along with that. So if there's any other questions people want me to address before I head that way, then throw those out. So leakage outdoors, all right? So this requires a blower door and a duct tester. And when I first started doing these tests and even started teaching it, this really was something I had a hard time visualizing, wrapping my head around, and then how do I explain it to other people? And it's a really common thing that I show up and have to explain leakage outside while I'm just standing in a room, trying to visualize or tell people, what's above us or where a blower door goes. So here's the illustration that I made that I think tries to explain how duct leakage to outdoors works. So here I have some, you can call these water pipes that are dripping water. These could also be ducts with leaking air, and they're continuing to leak, all right? And instead, I'm going to take this bottom section and I'm going to put it inside of a container. We can refer to this as our conditioned or thermal envelope. So I still have pipes that are leaking outside of this, and I have pipes that are leaking inside of it, or ducts. So once I start filling up the area below with water or pressure, then the bottom section can no longer leak. So my goal is to take the area that is my conditioned area and create an equal amount of pressure around the leaking ducts so that they can no longer leak inside. The only thing that can still leak is any kind of ductwork that's outside of this conditioned area. So it could be in the attic, could be in the crawl space. So wherever it is, it's just outside of this area that we consider to be the conditioned area. I do this by actually pressurizing this little area with the blower door. All right, so hopefully that helped with the visual. So whatever way you're going to test, you must do it the same way. So if for some reason you're going to pressurize your ducts, then you must pressurize the house with the blower door. All right, this can work either way. I've learned that if I explained it with pressurization, people have an easier concept of visualizing how it actually works, or it's easier to visualize things positively pressured than negatively pressured. So here's what we're going to set up. So I have my blower door, and it's going to be pressurizing as well as I'm pressurizing the duct. So I have everything set up to do this. All right. So I pressurize the house. That's the first setup that I do. And then the duct blower will then equalize. That's the technical phrase for the code is duct blower. So the duct blower will now equalize pressure. I'm not going to go to, I'll pause. We can either go to 0 or 25, depending on how you have it set up. But that's why I described it as I need equal pressure between the ducts and the conditioned area of the envelope. And once I have equal pressure, then the only place that the ducts can now leak is outside. So that's actually the premise behind how we set it up. And you can do the same thing in depressurization. So if you have your blower door, you're probably going to do a depressurization test. You should be depressurizing your ducts. And if you do it this way, there's nothing to change. You can actually just do one and then do the other and then do them together. So again, we depressurize the house. I'm depressurizing the ducts. and the area that's in the envelope will actually be eliminated as it's the leakage. So these are the two methods that you can do. Either, again, pressurize everything or depressurize everything. Again, you're probably already depressurizing your blower doors, so you should be doing the ducts. All right, so I came up with there's two ways to set up and run your test. One is if you're going to just set to 0, which means you're going to take your duct tester and set pressure to 0, right? Or you're going to set your duct tester up to reference outside, and then I can actually do set pressure 25. So I'm going to explain each of those and some of the challenges that go along with them. No matter what, you're always going to set the blower door to 25 pascals, and it'll either be pressurizing or depressurizing. So at this point, we're going to assume that we're going to depressurize each one of them so that they're all on the same page. All right, so our scenario on the left is the set to 0 concept. All right, so what that means that everything you have is set up identically as you normally do to do your blower door and your duct test. There's nothing to change, nothing to add. Everything is the same. Now, if I'm going to reference outside, then I'm going to be adding an additional tube on the channel A that instead of referencing the inside of the house, it will now reference outside. You actually can just combine that here in this little picture. I've combined it with my tube that already goes outside for the blower door. I just have a little T and combine them together. So you can see the illustration on the bottom in terms of adding and combining the red reference tube, or on the left, it's actually just the original setup. So we're going to go through the set to 0, and you can use your gauge or the speed control knob. So the blower door, again, always goes set 25, and then using the gauge to control the duct tester. One of the things I'd learned is that when you're going to use the gauge to do it, you're going to just hit set pressure 0, is that you must enter 0. So right now it says 0.0, and some people hit set, and it will not do anything. You must enter 0 and then hit set, and then it will actually go to 0 pascals and do that. And it does it over a very nice, slow, gradual method. It may take a little more than a minute to actually achieve that. Option B is to use the fan speed control knob that's on the fan, where I can just dial in the speed, or actually the pressure that I need in order to achieve 0 pascals. Either one will work fine for you. You're going to get the same reading out of the gauge. Your goal is to create a 0 pressure difference into the duct system based upon the blower door. So I have some visuals that also confirm that. So again, you can use the knob, or you can use the gauge to set to 0. One of the things, if you're going to do set pressure to 0 in the gauge, is that there is no at feature. You cannot do at 0. It just doesn't calculate that correctly. So most of the time you can get to 0. If not, then your challenge is that your leakage is too much for leakage to outdoors to get it to 0. So you either need to, again, alter your range or determine how low you can go with the documentation. Sometimes I've actually done set pressure, 0.1 or 1 pascal to get me close enough if I had to use the at feature. So say I can only get down to 4 pascals, then I can actually try and use that. But in general, it's rare that you cannot get back down to 0. So again, if I'm going to reference the outside, all right, so let me back up. My method is I don't use this, but I make sure people understand that this is an option. I just use the regular standard method of doing a duct test and the blower door, and then I just do set to 0 or turn the knob and get it back to 0. That's the best method, but because there are optional methods out there, I want to make sure they were covered and try to make sure I explain both of them separately. Okay, so here's my original total leakage setup that I have, all right? And here's the option where I'm actually going to add an additional tubing. So there's the yellow and green goes to the duct tester, and the blue, again, is always going to the nearest supply, just as I normally had set up. And I'm adding this additional red tube that actually will go to the outside over through the blower door. You can go outside anywhere you want, but you don't have many options of opening a window because you have a blower door trying to create a pressure difference. Okay, so here's how it kind of works all together. Again, my goal is to connect the gauge, connect my blue tubing. And notice that here, I want to make sure people understood the example of, normally I'm always referencing the inside of the house. That's why you open up a window. But if I'm going to add the blower door, I must close that. So that's my goal, is to make sure I'm referencing outside. Once I add the blower door as part of this, I can no longer have an openable window. So that gets closed, all right? And now I'm either going to add my reference to outside, or I'm going to just do a set to 0. So these are really your options on how you want to set it up. One of the things you can actually do is run this test directly from Virtual Gauge, which is actually a program that works on a PC that I can actually use Wi-Fi to connect my 2 gauges. And you can do this with one. I can explain that after I finish this visual. So I can actually tell my duct tester to go to 0, and tell my, let me back up. First, I always do is tell my blower door to go to 25. That's always the first step. And then my goal is that you end up with a, here I'd acted with a positive pressure that ended up in my gauge. And my goal is to have the duct tester push that pressure out, reaching near 0 or 0, and then give me my results. I'm checking to see if there's any kind of questions for this.
So a little bit of confusion about opening the window for the duct test. The question here is that if you're testing a house that's roughed in and it doesn't have an air barrier yet, do you still need to open a window when you're doing the total leakage test?
Probably not, but to me, there's always just things that I just do out of habit. So if you always have good habits, then you continue to do good habits. So if I, forgot to open up a window, then somehow maybe next time I forgot to open up a window. But to me, I always just start with, okay, this is set up, and then my tubing's set up. I open a window and I touch the gauge. So your house, older homes probably don't really have that much of an issue either, because they're so leaky. So mostly it's after tighter homes, but I guess it's your call as to whether or not you feel you need to do that. But in general, that's the best practice, is to always make sure that your ducts are open to the outside. And again, if there's no drywall separating them from attic or crawl space or any other conditions, because it's wide open, then there's nothing clearly to do for hatch, because you don't have one. Anything else that you had, Jay?
Nope, I think we're doing great.
All right. I got one more I'll throw at you. So I do not recommend this, but this is something that is acceptable in many of jurisdictions that's out there. So I thought that I would at least touch base on it. Before I do that, any other questions about leakage outside? So to sum up, for me, leakage outside is, I would do my blower door tests, seal the duct system, and do my duct leakage test, and then I can do them both together. And I usually just depressurize everything. So there's nothing to change, nothing to add. I would then reset and go blower door set 25, depressurize the house, and then either dial in or tell the gauge to go set to 0, and it will work its way back down to 0. And then that's my leakage to outside versus total leakage. The blower door, there's an unmodified and a modified subtraction method. Basically, it's designed to say my ducts are open and they're not sealed for this first test. The blower door measures the leakage with the ducts open as it normally does as a blower door test. So this is very common. You can do this at 25 or 50, but if you do it at 50, there's a conversion to bring it back to 25. All right. So ducts are supposed to be measured at 25 Pascal. So now my ducts are sealed, and now I actually have a different leakage of 1,025. So my first one was 1,250. And in theory, I could do, minus just the envelope, which is 1,025. So I could say that my duct leakage was 225 CFM. Some people find this to be fairly accurate. Some people say it's way off the mark. I don't find it to be the best method in terms of actually trying to perform a duct leakage test with just a blower door. There is something that tries to increase your accuracy, and that's actually to do a modified blower door. And that is, there's actually a chart that allows you to convert what actually could be your potential pressure difference inside the ducts to the envelope, and recalculate that and try to give you a better chance of being a little more accurate. So if you're going to do this, you definitely want to make sure you follow the modified blower subtraction method. That's in a lot of manuals that are out there. It may or may not be in the duct tester manual that we have for Retrotec. So I'm sure once I mention it, Colin will add it, and it'll probably be in there in a couple of days. I'm going to bypass the pressure pan. We've included that in lots of other webinars. So I want to move ahead to two things I want to plug real quick. One of which is we're getting close to having our final beta testing done and confirmation. So our cloud is coming to a tablet near you or a phone near you. And what's going to be amazing about this is that you'll be able to open up your tablet, geolocate where you're standing. In terms of code compliance, this is going to be a key feature that's out there for an enormous amount of testers and code officials. So I open it up. I basically just say, where am I? And it says, okay, you're here. And you confirm the actual physical address. It is able to geolocate where you're standing, even though the house that you're at may not be on the map yet. So you may be at a very new construction and the road's not even on the map yet, but it can actually determine here's where you were and bring it back up on a map just by geolocating you. So that's actually a key feature in terms of actually having an address that may not actually be established when you're doing your test at this new house. So I basically say, what kind of test am I doing? So I say, I'm going to do a duct test. And it'll connect to the gauge automatically and run a complete IECC single point duct test for you without you doing anything. In fact, the goal is you can't do anything, so that everything here could be considered unadulterated or unchanged, so that you're not entering anything manually. The goal is it says, okay, I confirmed where you were, and here's your results, and you can save them to the cloud or share your report instantly with your building official or the owner or the builder or anybody you want. You can actually send them the results directly from the site when you just got finished. So I think it's going to change what will be considered code compliant, is that you're going to have verifiable results that are geolocated and were considered to be unaltered results. So someone asked about the doing the subtraction method or using the blower door. So I will go on record as though I do not actually approve of this method or feel it is the best method to use. Some people may feel that's all I got, so that's what I got to use. So it can be done, and you can test at 25 or at 50. There's actually a calculation that shows up here, pardon me, that if you're going to convert, if you multiply your results by 0.64 to convert them back to CFM25. So if I'd done my blower door test at 50, then, and I get my results of the subtraction, I got to multiply them by, again, 0.064 to bring them back to 25 Pascal. I don't know where that number came from. There's a lot of things in the industry. I have no idea where those numbers come from, but they're just part of the industry. So, and here's actually the calculation that you can use to do that. Maybe that answers your question. Any other questions, comments out there? Anything that your particular building officials or municipalities are requiring that may not seem typical, or I guess one of my questions is how many of your code officials are requiring that they show up to see your test? That's the one that can be a troublesome or a challenging situation. The other is usually they want some type of document, which really can be just anything that's printed out on a a text edit or Microsoft Word document. Yeah, so someone asked to see this slide with the different options. And I will edit the slide so you can see what, here's the magic behind the scenes. That's how that works. So these are the different, pardon me, different compliance options. And if you're not sure where you should be at 4. If you're in a state that's now adopting 2009, do not feel overly comfortable with the fact that you're achieving less than 12, because within a year or two, you will need to achieve 4 or less. Air handlers are required now to be sealed by the manufacturer, and they're allowed to leak 2% of their capacity. So it's different than your square footage, but it's not far off. So they're allowed half of your leakage. Again, many people go back in and they're going to mastic the heck out of those units, but it is your goal to make sure that your ducts are as tight as possible. More and more people are spending, the $8, $10, $12 on the collars that are gasketed, because they are quicker and they actually make for a much better seal. A variety of things are out there are coming around to make your install better and faster, but they come with a price. Yeah, somebody asked about the 0.64, and that is the conversion to go from 25 to 50. That's actually what that is. So some people do the blower door subtraction method at 50 and then convert it, but you could do either one. Is what you can do. Eric Lowry says the code officials rarely require the test, and they never come see it. So I guess the question is, where are you at, Larry? What kind of area are you at?
Suburban Philly.
Okay. Thank you. Okay. Yeah, here in Georgia, they were the first to actually do duct testing and blower door. That was actually pretty amazing. And we require a compliance certificate that either goes on the air handler or in the electrical panel. It's not actually a sticker, but you could convert it to a sticker. The electrical panel can have issues with UL requirements, and it can be in the panel. Hopefully, it'll just stay there. That's always the challenge, as to where it will stay. So I wish there was something that was documented online, but everybody says there's no funding for that kind of stuff. But we're headed towards an era where we're just beginning to do this and do that, since what's a requirement now it won't be that long before it's just a given that these are how things work and what people do. Any other questions or comments? All right. So next Tuesday we'll be doing commercial duct testing. It is a completely different world, and we'll talk about mostly the larger commercial kind of a concepts, but it could be addressed on anything from the smaller restaurants to these large industrial complexes that are out there. Then the following 2 days after that, we have our amazing office party, and we hope you'll join us. And so someone's asked about, where do I go for formal training? I guess the question is, it depends on what you're looking to do. One of the things that is out there is the BPI has got a test or a certification that allows you, for the most states, to be able to do that type of testing. So I have a slide that kind of gives an overview of what that is. Here we go. So BPI provides what's called the IDL certification. That's Infiltration and Duct Leakage certification. This is just a test. You just have to show up and show that you know how to do a blower door test, how to do a duct test, and how to do a leakage outside test. And there's no written exam, and you are BPI certified as an IDL tester. And this was designed to allow the code officials to have something that they can refer to as, yes, this person is certified to perform just a basic new home construction type of testing that's required. This is not diagnostics. This is not how to determine cast testing or other issues. These are new homes. And to me, I just describe it as the blower door and duct tester are just really good tools. So it'd be like how to use a Milwaukee drill or a sander for the floor. This is just one other tool that's only designed to actually do compliance testing. Again, nothing is diagnostics. So feel free to reach out. You can actually reach out to me. The best email to give out would be support@retrotec.com, or training@retrotec.com, and I can actually get those emails from them. And then I can actually give you some leads on who actually is doing some of this. Any of the BPI training locations also offer it.
Yeah, Joe. So Mark mentions that if any of you guys are Retrotec customers, he'll provide tests. I'm assuming, Mark, you mean proctor tests at cost. So that's a great deal. Thanks for being part of the family, Mark.
Someone asked, will we cover balancing of commercial systems? I might. In fact, I'm going to wrap it up here any second because I got to go jump on a plane, and I'm going to Michigan to go work with some commercial duct testers all day tomorrow to get more pictures and learn some more of their processes that they do in the field, because that's not something I can do in my house of commercial duct testing. So, yeah. And if you want to get Mark's information, if you're interested in that, again, email something to training@retrotec.com, and we'll put you in contact with Mark. Here's your last chance. Any last comments? Phenomenal audience. We really appreciate your time. I can't thank you enough. If there's something that you want to see differently or things you want us to cover, please don't hesitate to send something to support or training at retrotec.com, and we'll get those emails. And we are looking for some new ideas or anything that's interesting to do for next year. We will be taking the holidays off. We'll be back in mid-January with more webinars. We did 56, that's 56 webinars this year. That's actually is more than one a week. And we're not sure how we did it, but we really had a great time doing it, and got a lot of great great slides, and we learned a lot ourselves. If you're going to do something, the best thing you could do is teach it, because you got to be on your game for that. So anyway, I'm going to call it a day. Jay, you want to take us out of here?
Yeah, thanks so much. Thanks everybody for coming. As always, we take it very, very seriously we take your time very seriously, and we're really, really glad that that you joined us and that you are sort of part of the family. So we look forward to giving you our Christmas gift. So thanks so much, or Hanukkah, I should say holiday gift. Thanks so much, guys. See you next week.